Happy Friday, everybody. Hope your Thursday went well and that you understood the lesson that I did and you didn't have any problems with your homework. If you did and you still have questions, please make sure you jot them down because I'll be back into the classroom on Monday and we can review that before we move on to the next section of Chapter 5. So I want to just make sure that you have this piece of paper. This was the paper that was eliminated from your Chapter 5 notes packet. It's the one I made a copy of and I gave it to you yesterday, Tuesday, during class time. So I'm hoping that you have it. You need it. It's page number 19, and it's the first part of this lesson. So what you're going to notice in your packet, this was page number 17, and you can see that we did our practice monitoring progress problems number 1, 2, and 3. And if you flip it over, you'll see all of a sudden it jumps to page 20. And so what I had to do is figure out or get you a copy of page 19, which is right here, and then you should have your packet, so you'll need page 20. So let me go ahead and get started with this lesson. This lesson is on solving special systems of linear equations. So let's just recap. What have we been doing? We've been solving a system by graphing. We've been solving a system by substituting. We've been solving a system by elimination. So in all three system methods, we always are getting an ordered pair as our solution. There's one value of x and one value of y that we're looking for when we're graphing or substituting or eliminating. So today we are going to ask the essential question of, can a system of linear equations have no solutions or infinitely many solutions? And I'm going to add one more to that, or just one solution. So let's take a look at our learning objective for today. By the end of this lesson, you're going to be able to determine the number of solutions of a linear system, and again, use linear systems to solve a real-life problem. So let's get started at first looking at determining the number of solutions. So the number of solutions can be one option, no solution. So what do I mean by that? Well, let's take a look at this example. In this example, we have a system of linear equations. Y is equal to 2x plus 1 and y is equal to 2x minus 5. So what we're going to do is I want you to just, what do you notice about these systems or these two equations? Well, maybe you noticed that they both had the same slope. Well, let's see what happens if I were to graph each one of these equations on this graph right here. So we're going to solve by graphing. I'm going to start with 2x plus 1 by going on the 1 axis, the y-intercept, and I'm going to go up to 1, 2, and over 1, up 2 and over 1. And I'm going to follow and continue down. I'm going to go down 2 and over 1, down 2 over 1, down 2 over 1, because I like to include all of my points if I'm given a graph. So I'm going to go ahead and draw my line with my arrows. So now I'm going to go ahead and I'm going to draw the second equation, 2x minus 5. So that means I'm going to start at negative 5, 1, 2, 3, 4, 5 right here. And I'm going to go up 2 and over 1, up 2, over 1, up 2, over 1, up 2, over 1. I'll continue till I end. And now I'm going to draw this line. And what do you notice? Well, you should have noticed that based on the fact that both the slopes were the same, so the slopes are the same, therefore, they're parallel lines. And I remember when I asked you for the definition of parallel lines, you told me that they never cross. And that was absolutely accurate and true. So if parallel lines never cross, then I can say there is no solution to this system. Because remember, a system will have an intersecting point, and that is my ordered pair. Well, in this case, I've got two parallel lines, therefore they won't cross. So let's just verify again, because we don't always have a graph to graph things with. So let's take a look at what happens when I solve by substituting. Well, take a look that this equation 2x plus 1 and this equation 2x minus 5 are both equal to y. Therefore, I can put these two equations equal to each other. Remember what I wanted to say is I want to solve for the value of x. So how would I do that? Well, I'm going to take 2x away from this side and 2x away from this side. And I'm left with 0. I'm going to bring down my equal sign. I'm going to go 0 plus 1 is that goes away, is equal to negative 5. Well, I want you to notice something. 0 plus 1 equaling negative 5. Well, 1 cannot equal negative 5. Therefore, take a look. No solution. Doesn't exist. Doesn't happen. So, that is solving a system with no solution. We will often have parallel lines and my slopes are the same. So, one of the things I want to make sure that you write in the discuss and explain boxes down here. What do you notice about solving using a graph, using substitution? So what did we just discuss? And what is the slope of both lines? What does that tell you? What do you know about parallel lines? So you should go back in and you should definitely answer those questions. So now I'm going to go ahead and move on to page 20. Again, remember this is 19. Now I'm going to find page 20, which is right here. And now I'm going to look at example 2. And example 2 has to do with solving a system that has infinitely many solutions. So we've seen one that has no solutions. Now let's look at what happens when I've got infinitely many solutions. So again, you can see I have 2x plus y is equal to 3. That's equation 1. I have negative 4x plus 2y is equal to 6. Well, take a look. It tells me to use graphing in order to be able to solve. Well, in order for me to be able to easily graph this, I need to make sure I convert each one of these equations into y is equal to mx plus b. Please remember that this is the slope-intercept form. And again, just to repeat, how do I know it's slope-intercept? Because I've got the slope and I've got b as my intercept. So I'm going to turn that into y is equal to mx plus b by converting and moving equation 1 to the format of y is equal to 2x plus 3. And I'm going to go ahead and I am going to graph that. I'm going to start at 3, so 1, 2, 3, drop my point at my y-intercept, and then I'm going to go up 2 and over 1. And you can see I can't go any farther, so that means I can go down 2 and over 1, down 2 over 1, down 2 over 1, down 2 over 1. And I've got a nice line or a nice set of points that I could easily graph. And I've got my first point, my first line there. So now I need to convert or move this equation into y is equal to mx plus b. So the very first thing I'm going to do is I'm going to add 4x to both sides, which leaves me with 2y is equal to 4x plus 6. Then I'm going to go through and I'm going to divide everything by 2. And when I do that, what do I get? I get y is equal to 2x plus 3. So take a look there. What do I have? I have the exact same equation. Therefore, if I have the exact same equation, they're basically superimposed on one another, and I can put any x value into the equation, and it'll always make this true. So this is an infinitely many solutions. Okay, that's by graphing. So now let's look at eliminating. So I'm going to go ahead, take a look what I've got up here, and I'm going to notice that if I were to multiply this whole equation by negative 2, remember I want to eliminate. So if I multiply that by negative 2, that becomes positive 4x, and that'll, if I take 4x away from 4x, well then I get 0. So let's go ahead and do that. So I'm going to multiply, and in other words, I'm distributing across everything. I'm multiplying every single term by negative 2. So I get 4x minus 2y is equal to minus 6. I'm then going to go in and I'm going to write this problem, negative 4x plus 2y is equal to 6. I'm going to add down, oh, that's 0. Oh my goodness, that's 0 again, and that's equal to 0. Well, this is definitely true. 0 plus 0 definitely equals 0. In other words, I could say 0 is equal to 0, absolutely. Therefore, by elimination, I can say I have got infinitely many solutions. And what that means is I can put any value of x into this equation and it'll always be true. Same thing with y. So anything will work. I can put any amount in. So now what I'd like you to do is go in and I'd like you to please fill out the discuss and explain. What did you notice about solving using a graph? What happened when we used elimination? And what does that tell you? So then what I'd like you to do is please go in and solve this system, the practice, number 1 and number 2, for sure. Then what I'd like you to do is find, and I need to do that right here, so I've got 17, I'm on 20, there's 19, look at 21. I want you to go in, please, and do number 3 and number 4 on page 21. So that's your practice in order for the monitoring progress, so that's what you do on your own. And what I'll do is I'll go in and I'll give you the answers. So I wanted to show you number 1 for practicing your monitoring progress. You should have gotten infinitely many solutions. And for number 2, I want to point something out at you. I want you to notice that this is in y is equal to negative x plus 3, which is in the format of y is equal to mx plus b. Notice that this is in standard form. So what I'm going to suggest that you do is, given that this is in y is equal to mx plus b, I'm going to convert this into y is equal to mx plus b. So I'm going to move this and I'm going to say 2y is equal to minus 2x plus 4. I'm going to divide everything by 2. And when I do that, what do I get? Y is equal to negative x plus 2. So take a look. Negative 1x, negative 1x. What does that tell you? It tells you that my slopes are the same. Therefore, my lines are parallel. and therefore no solution because the lines never cross. So I'm going to go ahead and do number 3 and number 4, and then you can check your work. So as you could see on problems number 3 and number 4, what I did here was I noticed that I had x and y is equal to 3 and x plus 2y is equal to 4. So I could have either multiplied the top by -2, but what I did instead was I multiplied the bottom by -1, turning this into a -x minus 2y. So you could see here what I did. And then I got -y is equal to -1, therefore y is equal to 1. Then I took that value of y, plugged it back in, and I got now that the value of x is 2. So this is one solution. That's all I got, is I have one point of intersection, which is what we had seen in all the previous lessons that we've been doing to date. For number 4, I'm going to notice, and one of the things that I do is that I pay attention to how these equations are being formatted. So one of the things I noticed that this is already in y is equal to mx plus b. And if that's the case, what I did then is I converted this equation into y is equal to mx plus b, which left me with y is equal to -10x plus 10. I circled my slopes for both of them, therefore, same slope, therefore they're parallel lines, which means no solution. So the very last thing I'd like you to do is I'd like you to write a system of equation that has no solution. Write a system of equation that has infinitely many solutions. So make it up and then try it, because that's a great way to make sure that you understand it deeply. So now that's the lesson for today, and I want to just make sure that you have the homework for the weekend. So your homework for the weekend is a yellow sheet of paper. It's lesson 5-4, homework extra practice. What I'd like you to do is I need you to do only problems number 1, 5, 6, 7, 13, and 15. That's the only thing that you have to do, are 6 problems. This is due on Monday. And next week, what we're going to do is on Monday, we're going to start with inequality work, and then we'll be ready to take our test at the end of next week. Okay, so make sure you keep up to date. Go back and listen to these videos if you need to on lessons 5-3. Today was 5-4. Make sure you get all your homework done, and I will see you on Monday.